Hello, good day. Welcome back to our YouTube channel. If you're new here, welcome. My name is Steve Lab, and I'm going to make your learning experience enjoyable. So today we are just going to deal with free body diagrams and how to formulate the equations of motion using the free body diagram. So sit back, relax, and enjoy. So I'm going to show you how to take out the important information when you are reading the statement. So this statement that they gave us, let's see how we can make sense of it. So for understanding purposes, let's take this maybe as our block A and this one as our block B. So they said a block of mass 2 kg. So already they told us that this is having mass. So anything that has mass, it means that it has the Fg. So A, we have gravitational force. So that's one of the forces that it will have resting on a rough horizontal table. So it is resting on a rough table. So it means that it will have the frictional force as well as the normal force because it is on a surface. So it will also have the normal force. Is connected by light inextensible string. So already we know that it is connected by a string. So definitely there will be tension there. And then it's connected to another block of mass 5 kg. So this is the other block of mass 5 kg. So let's see what is important on that block. So this 5 kg block hangs vertically as shown in the diagram. So it means that our block B is going to have Fg as well because it is having the mass and also tension because it is connected to that other block. A force of 40 newtons is applied to the block of mass 2 kg at an angle of 15 degrees. So also on this block A, we are also going to have the force applied, causing the block to accelerate to the right at a constant acceleration. So it means that these objects are going to the right. So remember, if the motion is towards the right, it means that the frictional force will be at the opposite direction. Always remember that. Okay, so let's maybe just formulate the equations of motion and the free body diagrams of these blocks. So let's see now. Let's start with maybe block B. So let's see how we can deal with block B there. So our block B, it is having, we said it is having weight and tension. But since the objects are going to the right, so it means that this object is going down like that. So it means that we can draw our free body diagram in this manner. So it means that our Fg, and then also it will have tension because this is the object that is in front. So it means that the tension will be going backwards on this object. So now, how do you formulate our equation of motion on block B? So straightforward, we know that F net is equals to mass by acceleration. So this block, we can see that we're having two forces only acting on block B. So we said, what is F net? It is the sum of all forces acting on an object. So we say that Fg plus tension will be equivalent to mass by acceleration. But now in terms of the direction, we said mostly we take the direction of motion as the positive direction. So it means that our tension will be negative and our Fg will be positive. So this will give us Fg plus minus tension is equals to mass by acceleration, just like that. So that is all about block B. So let's go to block A. Let's see what we can make sense of block A. So on block A, let's draw it here. So how many forces did we see on A? We saw that it is having Fg, frictional force, normal force, tension, and force applied. There are 5 forces acting on that. So the free body diagram of this, we are going to draw it like that. So first, let's insert its normal force. So it means that it is having normal force to start with, and it will also have Fg. You forgive my drawing, I'm not that much good drawer. And we have normal force, but the motion of this object is going that way, so it means that our frictional force, it will be in the opposite direction. So this will be our frictional force, and we also know that we're having a force acting at an angle, so we can insert that force at an angle, which is the force applied. It is acting at an angle theta there. And we also have the tension that is pulling this object, so also have the tension like that. So all 5 forces are shown there. So now, how do we formulate the equation of motion using this now? So let's see all the forces that we are going to have and how it is going to play out. So what do we know? Beforehand, we know that our F net is equal to mass by acceleration. But here, how many forces are acting parallel to the plane? So we have tension, it is acting parallel to the plane. We have frictional force, it is acting parallel to the plane. And we also have F at x, it is also acting parallel to the plane. So don't forget that F at x is found using F cos of theta, right? So let's see how we can formulate the equation here. So it means that this is tension plus, but you can see that our frictional force is going in the opposite direction, so minus frictional force plus, and we also have F at x, which is acting parallel to the plane, so plus minus F at x. This should be equivalent to mass by acceleration, just like that. These are the 2 equations of motion that we are going to, you can see how we do this, right? So maybe let me come with other examples on how to formulate the equations of motion.